Hello everyone, I'm Sebastian Y and this is Foundations of Economics. In this video we're going to talk about cost curves in the short run and the long run. In the previous video we introduced the production function and then used that to build the total cost function. We're now going to dig a little bit more into the cost function. We're going to start out by continuing to think just about the short run. Remember that in the short run some inputs are fixed and some are variable. As such, we can break down our total cost into two parts: fixed cost and variable cost. Fixed cost is the cost of those fixed inputs. In the short run, we're going to generally consider capital to be our fixed input, so the fixed cost is going to be the cost of whatever amount of capital we currently have. Fixed cost does not change when output changes, because the inputs cannot be changed, at least in the short run. Variable cost is the cost of the variable inputs. In the short run, we generally think of the variable input being labor. Unlike fixed cost, variable cost does change when our total output changes. We're going to use a Q for short to represent our total output. Q stands for quantity. We're going to abbreviate these as TC, FC, and VC. The relationship between these three must be total cost is the sum of the fixed and variable costs. For the rest of this video, we are going to consider a new example. Consider a factory which produces gizmos. Gizmos could be anything you want. In the short run, the amount of capital is fixed. We're going to assume that our factory has some amount of capital that they rent for a cost of 600. That means our fixed cost is going to be 600. In the short run, the only way to increase total output is by increasing labor. The more output we want, the more labor we have to hire, so the cost of labor is going to be our variable cost. This table shows the relationship between our quantity of output with our fixed cost, variable cost, and total cost. Fixed cost stays at 600 no matter what, but variable cost goes up because the more quantity we want to produce, the more labor we have to hire, therefore increasing cost. This also shows the relationship between fixed cost, variable cost, and total cost, where total cost is the sum of fixed cost and variable cost. Just like with the production function, we can represent our cost function in three ways: a schedule, a graph, and an equation. We are again going to only look at the schedules and the graphs in this course because using the equations is going to require a little bit of calculus, and so we are going to save that for a later course. Consider the following two questions. Number one, what is the average cost to produce one gizmo? And number two, what is the cost to produce one additional gizmo? These two questions seem similar at first, but the answers to those are not necessarily the same. To compute the average cost, we want to see how the total cost is spread out over all of the units of output. To calculate the average total cost, which we abbreviate ATC, we are going to take the total cost of whatever quantity we're producing and divide that by the quantity of output. We can calculate the average fixed cost and the average variable cost in much the same way. For average fixed cost, AFC is going to be the fixed cost divided by total quantity, and AVC, the variable cost divided by the total quantity. Since fixed cost and variable cost add up to total cost, it must also be that the average total cost is the sum of the average fixed cost and average variable cost. Let's go back to our table and calculate these average costs. Starting at quantity of 1, for average fixed cost, we take the fixed cost of 600 divided by 1. We get 600. For the average variable cost, we have a variable cost of 40. Divide that by quantity of 1 is 40. Average total cost, we can get two ways. We can take the total cost of 640 and divide that by 1, or we can take the sum of the average fixed and variable costs. Either way, we're going to get 640. At 2 output, 600 is now divided by 2 for the average fixed cost, so we get 300. Average variable cost is going to be 120 divided by 2, so we have 60. Average total cost, we can either take 720 divided by 2 or add 360 to get 360. We can then continue this process all the way down. Next, we're going to answer the question of what does it cost to produce an additional unit of output? For that, we're going to need the concept of marginal cost. We define the marginal cost as the change in the total cost divided by the change in quantity of output. This is going to tell us what it costs to produce one additional unit of output. Usually, we are going to just be thinking about 1 unit increases anyway, so we'll be changing the total cost divided by 1. The marginal cost is the slope of the total cost curve. Going from 0 units to 1 unit, we go from 600 total cost to 400, so our marginal cost will be 40. Going from 1 unit to 2 units, we go from 640 to 720. That's an increase of 80. Going from 2 units to 3 units, we go from 720 to 840, an increase of 120. Notice also that since the fixed cost never changes, the marginal cost is also just the change in the variable cost. We can then go ahead and fill in the rest of this column. Notice that the marginal cost starts out low and rises as the quantity increases. This means that each individual unit of output adds to the total cost more than the last one did. This happens because of diminishing marginal product. Once we already have a large amount of output, to increase output, we are going to need to add a lot of labor because of the crowding problem. This makes the marginal cost higher when we already have a high amount of output. Let's take a look at the graph of the total cost function. Notice that the total cost function gets steeper as quantity goes up. This is reflected by the rising marginal cost. The marginal cost is the slope of the total cost function. As marginal cost goes up, the total cost curve gets steeper. We're now looking at a graph of our average fixed cost, average variable cost, average total cost, and marginal cost curves. These 4 together are known as the 4 short-run cost curves. First of all, comparing the marginal cost and the average total cost, these are the answers to those 2 questions. What is the cost to produce an average unit of output, and what is the cost of producing an additional unit of output? These 2 curves are not the same. We can also see the relationship between the average fixed cost, average variable cost, and average total cost. The average total cost is the sum of the average fixed cost and average variable cost. Notice that average fixed cost starts out very high because we have our 600 fixed cost spread over a small number of units, but as the number of units of output increases, the fixed cost comes down. The fixed cost is a constant number divided by a larger and larger denominator, and so the average fixed cost must always drop as quantity increases. At the same time, the average variable cost is increasing. What we get from this is an average total cost curve that starts out high, but quickly drops as average fixed cost drops, but eventually the average variable cost continues to increase, which will eventually start pulling the average total cost up. This always makes the average total cost a U shape. The point at which marginal cost crosses average total cost, right here, always happens at the lowest point of the average total cost. And the quantity that happens at is called the efficient scale. Looking at our graph, we can see that at a quantity of 5, our average total cost is 240, and at a quantity of 6, our average total cost stays at 140, and after that it starts to go up. That is also the point where marginal cost is also equal to 240, the point where they cross. Notice that at quantities lower than 6, the average total cost is coming down, and at quantities greater than 6, the average total cost is coming up. That corresponds with quantities where the marginal cost is below the average total cost, and quantities where the marginal cost is above the average total cost. Remember that the marginal cost is the cost of an additional unit of output. If the cost of that additional unit of output is below the average, it pulls the average down. If the additional units of output cost more than the average, they pull the average up. You can think about this very similarly to your GPA. If you get a grade that's below your current GPA, that's going to lower the GPA. If you get a grade that's above your current GPA, that's going to raise it up. This is just one example of how the cost curves are going to look. I'm going to sketch a graph of what we might consider typical short-run cost curves. We'll start with the average fixed cost. As we discussed before, the fixed cost is constant, so the average fixed cost is always going to be decreasing. The AFC will asymptotically approach zero as quantity gets bigger. A typical marginal cost curve will look something like this. It starts out a little bit higher, but initially drops. The reason for this is that at a low quantity of output, we generally have a small number of employees. Each of those employees have to accomplish a bunch of different tasks, and they might not be able to do that in the most efficient way. Consider the example of a bakery. If we only have one employee, that one employee is going to have to mix the dough, knead the dough, shape the loaves, watch the oven, and also clean up. But if we want to produce a little bit more output and we hire some more workers, they can start to specialize in their different jobs. That might make things more efficient, so our marginal cost is initially going to start to come down. But pretty soon, we're going to get to a point where there's no more gains to be made from specializing, and adding more workers is only going to make the bakery more crowded, which increases the marginal cost. So inevitably, marginal cost will start to come up. This is what gives us a kind of checkmark shape to the marginal cost curve. When the marginal cost curve has this checkmark shape, the average variable cost will have a U shape that crosses the marginal cost at its lowest point. And it's going to start coming up. The average total cost curve is going to be the sum of the average variable cost and average total cost curves. The average total cost curve will be the sum of the average fixed cost and average variable cost. So that's going to start out high, but will quickly drop as the average fixed cost also quickly drops, and will eventually cross the marginal cost at its lowest point and then start coming up again. As the average fixed cost approaches zero, the distance between the average variable cost and average total cost curves will shrink. When we sketch these cost curves, we need to make sure that they adhere to these general properties. The average variable cost crosses the marginal cost at its lowest point. The average total cost curve crosses marginal cost at its lowest point. Remember that this quantity right here is called the efficient scale, the point at which average total cost is minimized. The cost curves that I just drew are reflective of a general class of cost functions that we call cubic cost functions that have a convenient algebraic representation, but we're not going to get into that in this course. For now, I just want you to think about the general properties of what we would think of as typical short-run cost curves. Our final topic here is to think a little bit about the long run. Remember that in the long run, all inputs are variable and none are fixed. This means that firms can choose both labor and capital and can choose them to minimize the total cost. This differs from the short run, where capital is fixed and the firm can only choose labor. Whatever amount of capital they had in the short run, they're stuck with until the long run. That particular amount of capital might be a good amount of capital for certain amounts of output, but not for others. For example, if we are starting out with a small factory and want to produce a very large amount of output, the only thing we can do is cram more workers in there, which is really inefficient. On the other hand, if we have a really large factory but want to produce a small amount of output, we can put a small amount of workers in there, but we have a huge amount of wasted factory space that is costing us money. In the long run, we don't have these problems because we can adjust the amount of capital, including the factory size. This means that in general, for any given quantity, the long run average total cost is lower than the short run average total cost because we can optimize better. Increasing output in the long run means increasing all inputs. We're going to think about 3 different situations that can arise. First, as quantity increases, then the long-run average total cost decreases. This means that as the firm gets bigger and produces more output, it becomes more efficient. This is what we call economies of scale. It's more efficient to produce more units of output. Returning to our bakery example, one reason why this might happen is that the bakery gets bulk discounts on ingredients. Specialization of resources can also be a factor here, as we discussed before. The second possibility is that as quantity increases, the long-run average total cost increases. This means that the firm is getting less efficient as it increases in size, which we call diseconomies of scale. Usually this happens because a firm gets so big that it starts to have coordination problems. The large American automobile manufacturers are often raised as an example of diseconomies of scale. Companies like General Motors have so many different things going on that they suffer from coordination problems and become less efficient as they get bigger. The third possibility is that as quantity goes up, then the long-run average total cost stays the same. This is what we call constant returns to scale. The average total cost is increasing at a constant rate. So if quantity were to double, then the total cost would also double, leaving the average total cost the same. This concludes our introduction to production and cost. We've covered a lot of technical terms here that are important to keep in mind as we move forward thinking about different types of market structures. If you have any questions, feel free to let me know. Thanks for watching.